Hey everyone! Are you tired of solving systems of equations using elimination and substitution? Well, they're great sometimes, but when you have huge systems like this, it can get annoying. So, matrices give us a lot of different options for new ways to solve systems of equations. So the way we're going to focus on today involves inverses. So solving system of equation of inverses involves first setting up our system equations as matrices. So what you're going to do is you're going to take the coefficients of the x's and y's and put them in a matrix. Then those being multiplied by x and y would give you this side of the matrix. And then it equals the right side. So it equals 9 and 10. So I have now turned my system of equations into matrices. And if I multiply this out, you would get that system. So I'm going to call this matrix A, this matrix X, and this matrix B. So over here, I have the setup for how we can use to solve for x and y, how we can use inverses to solve for x and y. So we have this A times x equals B, but our goal is to get x by itself. So to get rid of A, we multiply by the inverse of A. We know when you multiply by the inverse of a number, so like 2 times 1/2, you get 1. So that's a way to move it from one side to the other. So we're going to multiply both sides by the inverse to make A leave this side. So now we've just got x on this side, and on the right side we've got the inverse of A times B. So in order to get this xy, we're going to multiply the inverse of A times matrix B. So what it'll look like is xy equals, we've got matrix A, the inverse, times B. So if you had a calculator, you could just type this in. However, I do want to teach you how to do it by hand so that we can practice that as well. So to find an inverse, we learned last class that you do 1 over the determinant. So determinant is 5 times 2 is 10, minus 4 times 2 is 8. And then you're multiplying by the adjunct matrix, so you're going to switch the first diagonal, so you give 2 and 5, and you do opposites of the second diagonal, so -4, -2. And then that's being multiplied still by our 9 and 10. So the way I used to do this when I was a matrix noob is I would first do my fraction, multiply that in, and then multiply a matrix with a bunch of fractions into this. So you can do that. Personally, I've found that I don't really like having fractions, so I keep this until the end. So as we go, I'm going to leave that 1/2, which comes from the 10 minus 8 in the front. And I'm going to start multiplying these together. So I'm going to do row times column. So that'll give us 18 plus -40. And then there's no more columns, so we're going to switch to the next row times column. So -18 plus 50. So still have that 1/2 in the front. When I add those all together, I get -22. And 32. Be careful with your mental math. I did this wrong the first time I did it. And now is a good time to multiply in that 1/2. If we had done it at this stage, we would have gotten a few fractions. Maybe only one, but it still is just nice to not have those fractions until the very end. So multiplying that in, we get -11 and 16. So you're just multiplying the scalar by both of those values. So what that tells me is that the x value equals -11 and the y value equals 16. So yes, it might have been faster to solve that using elimination or substitution, but if you had a calculator, that's really fast to type into a calculator. I just want you to know how to do it by hand. I'll show one more by hand really quick. So setting this up, I'm just going to jump to the, it's going to look like -1, 10, 2, -10. We want to find the inverse of that, and we're going to multiply by -5, 1. If you want to skip this example, feel free, and you can go jump to the last one. So I'd start with finding the determinant of this matrix. So 1 divided by the determinant. So 1 over multiply here, we've got 10, minus multiply here, we get 20. We switch the first diagonal, so -10, -1, and switch the signs of the second diagonal. Then I would recommend multiplying together the two matrices, because otherwise we're going to get a bunch of fractions. So it now looks like 1 over -10. And then we're going to do row times column. So 50 plus negative 10, the row by the next column, so 10 plus negative 1. So we're left with 1 over negative 10, 40 over 9. And now if we multiply this in, we get negative 4 over negative 9 tenths. So what that tells me is x equals negative 4 and y equals negative 9 tenths. That didn't take too long. All right, so that is how it's done if you just have an x and a y. So yes, you could have used elimination or substitution, but when you get to a problem like this, that's annoying to do elimination or substitution. So setting up that system looks the same. So I took the coefficients from the left side, put them in a matrix, take the inverse of it, and multiply it by the answer column. So I would just type this into my calculator. That's how I got these values. So you saw videos on how to use each of the 3 different calculators. Really quick, here is what it looks like on Desmos. So I entered in matrix A, matrix B, and then I typed in A, did the inverse button, and then typed in B, and it found the solutions for me. All right, so now you have seen how to solve systems of equations using inverses. So happy travels and good luck on your practice problems.